What's up, best friends? My name is Brian Deach. With me, I have the infamous Jeff McDaniel. Not McDaniels. There's only one of them. Jeff, who are you, and where are you from, my friend?
Hi, nice to meet everyone. From Airgap, the actual recent acquisition by Zscaler.
Right on, brother. Well, that's actually a great segue. So if you're tuning in to talk about cloud security, we're actually not doing that today. We're talking about your data center, right? And where Airgap kind of fits in place. So when we talk about the data center, we're going to jump right into it. We'll say that like this is the core of your network. And what is at the core of your network connected to those routers and switches? Going to have some hosts that are out there. So we got host 1, host 2, host 3, host H2O. I don't know. Dad joke of the day.
Well, there's H3O now, right? Heard that.
You're not mistaken. You're absolutely correct. And we'll say like host 6. And realistically, if we're going to give a good example here, maybe host 1, 2, and 3, this is like our user kind of VLAN. And we'll call that VLAN 200. And then over here, maybe this is like an OT network, and that's VLAN 300. And generally speaking, right, when we think about firewalling and stuff, you'll do a firewall in between VLAN 200 and 300. So we'll come over here, draw a little firewall off of this. And generally speaking, these firewalls going to have an IP address into these VLANs. So we'll say, for argument's sake, 10.10.20.1 for VLAN 200, and 10.10.30.1 for VLAN 300, the OT network. And firewalls do a really good job of like that north to south segmentation, but the east to west story has been a little bit trickier. Maybe you've done it with things like NSX or Guardicore, Tetration. I have no idea, right? Those technologies are so old and they can have child support and alimony at this point in time. This is definitely a newer way of looking at it. So when we think about this, let's take host 1 and look at it from a configuration standpoint at an IP level. So it's going to have an IP address of 10.10.20.100, and it's going to be on like a /24, which means its gateway IP address is going to be the firewall. I think we all get that. So 10.10.20.1, how you can do the segmentation between those things. But when we look at this, the story kind of falls short, especially when you're trying to do microsegmentation on either one of these VLANs. And so this is really kind of our before state of how things look. And so let's introduce Zscaler into the picture. So believe it or not, we're talking appliance. And Jeff, correct me if I'm wrong. Is it a physical or is it a virtual or is it both?
Can be both. And it can be a mix. You could have one virtual and one physical in a cluster.
Gotcha. So we have a cluster of good stuff right here. My pen is acting up. We'll fill in the dots as we go. But this is going to be the big bad Zscaler box to kind of rule them all. This is Airgap technology at its best. And the reality is it's going to be plugged basically into the network as well. And is this managed locally or is it cloud managed? I'm curious what that actually looks like.
Yep, so our management plane is in the cloud, in AWS. So when you're creating your policy constructs, that's done in the cloud, and the gateways check in with the management portal every 20 to 40 seconds, just asking, hey, is there anything new for me? And if it is, then it'll download it and apply it locally.
Right on. And so to get the enforcement here, I guess at some point in time, we have to get the traffic between like host 1 and host, let's call it 3, like this direction. We have to figure out a way to kind of isolate this and be able to do it. And really, from what I understand, is we want to actually move these IP addresses over here. So these IP addresses that were on the firewall, it's going to be moved over here. So 10.10.20.1 and 30.1. Is that like is it called SVI? I'm not a network guy. What is it? What are we doing?
Yeah, SVI. So that could be on the firewall or it could be on the switch. We'll migrate the SVI. And by the way, that process for Airgap, with Zscaler Airgap, is a non-disruptive process when we do that, right?
Beautiful.
Which is nice. Makes it very nice.
All right, so I'm curious. The after state, we'll come over here. Thinking, what's that going to look like? This from host one, and we can kind of extrapolate that across all the hosts. But host one is going to come through here. I'm going to imagine that the IP address is probably going to stay the same. So 10, 10, 20.100. But the cool stuff that we're doing here is that we're gonna switch it from a /24 to a /32. Is that correct?
That is correct, yes.
So we're like Oprah. Every host on VLAN 200 and 300 for this use case going to get their own little /32. Yes, so you get a /32, you get a /32, and all that good stuff. And so then the gateway doesn't change either. It stays the same, but now to kind of connect the dots, the gateway is going to change from red to blue at the end of the day. So it's still going to be 10, 10, 20.1. But now what we're going to do is we're going to take that traffic and kind of enforce it through Zscaler Airgap. Is that correct?
That is correct. Absolutely.
All right. So let's talk a little bit about control, and hopefully you can take over here from me.
Sure.
Let's use host one to host three. Like, what does that actually look like?
So what happens, first of all, the main benefit of the Zscaler Airgap microsegmentation is you and I are talking about host one as a fact that, we know what it is, right? We know what the IP address is. Maybe it's a device where somebody's just plugged into the network, right, and just got an IP address automatically, or maybe they've statically configured a network IP address, and they just maybe want to perform some, seek out and destroy kind of methods on your network. So Airgap actually sees those devices, whether they're authorized or not on the network, and then we're able to apply policy and control. So we give you the visibility, right, what's on the network, but then give you the telemetry data to say what are they doing, and then we can apply policy to say yes, we want to allow that, or no, we don't.
So policy and control. So it's almost like we're wrapping each host around with its own type of identity-based ACL, or is that what I'm understanding?
Almost like a network of its own, or network of one is what we would call it. So then what makes that nice is you think about what Zscaler has done, the past bunch of years, right? We're talking about machine-to-machine and user-to-machine control. Airgap was founded with those very same principles. That's what makes the marrying of the technologies and the ideas between the two organizations of zero trust. As Jay says, you map the user, right, not to the network. You map the user to the application, and Airgap can now extend that to the actual local network. So we can have a machine-to-machine or a user-to-machine policy control.
The microsegmentation story for like VLAN 200, it makes complete sense. I do wonder, as I have maybe a workload, a user going in this direction, H1 down to H4, like host 1 to host 4. Traditionally, I've done that with my firewall, but I'm assuming that maybe I don't need that. Is that correct?
Right. So you don't need the firewall. Airgap can give you visibility and control of not only east-west traffic, but north-south traffic. So as Zscaler expands their technology footprint, right, we're talking about easier implementation. We're talking about quicker implementation. We're talking about vendor consolidation, right? Why need a firewall and an expert, and then a different route switch expert, and then a different expert that's works on an agent, right? It's basically one person or a group of people performing the same functions of zero trust.
Yeah, I'm starting to wonder if we even need to have that firewall. So I get it. We get control, but man, building that policy, right? There's got to be maybe some best practices since you guys have been doing it a while. What would you recommend, or how do we even do that? Is I think the better question.
Yeah, that's a great question. So just very quickly, we go into learning mode when we first install, when we first implement. So we're able to actually look at the traffic patterns. Some of them may be normal, some of them may not be, and we can start applying some best practices. So in the user VLAN, what makes it very nice is We could say allow no lateral communication in the user VLAN, right? We could do that. We could also say, and this is Airgap's best practice, is let's just knock down the most insecure protocols that ransomware and malware uses. So if you're in the user VLAN 200, there's no lateral SMB, Kerberos, there's no RDP, there's no SSH. By doing that, we actually knock the attack surface down about 90%. So we get a very small attack surface now in the user VLAN.
You read my mind. I was going to ask you, what are the vulnerable protocols that are out there? And you hit the nail right on the head. So yeah, looking at this, right, I think the architecture is pretty simple. I look at it from a control perspective. We can do really cool things. Since it is a network of one, what would happen if host 3, right, for some reason is running amok and doing bad things? What kind of control can we actually do there? From maybe an orchestration standpoint, simplicity standpoint, what can we do there?
Right. So Airgap has, we have our ransomware kill switch. So think of automated incident response planning. So there's a bunch of things we can do, and this can be automatic. This can be manual. So we could say just quarantine host 3, right? That might be a simple answer. The other answer might be, hey, host 3 is using RDP to communicate to host 1. We don't want that. Just stop the port or protocol, right? The other outcome could be, hey, there's malware that's been detected on H3 from the EDR. So you know what, Airgap, go ahead and quarantine the entire VLAN until forensics can be performed on the VLAN, and then we'll relax the control.
So it kind of feels like we're taking host 3 out to the train station as a popular analogy for that. That's actually pretty cool. So I guess to sum it up, the architecture is pretty simple. There's control, there's visibility, lots of best practices, 100% sure we can meet you in the scalability needs. And the last thing, I'll tease it out. Obviously, this makes sense from the data center, but if you're a current customer and you have Zscaler private access, little teaser here, think about how we can integrate that in the future. So with that said, Jeff, do you have any parting words before we wrap it up?
You know what? Microsegment and be safe, my friends.
Make microsegmentation fun again, right? Thank you for watching this video. Please reach out to me. Please reach out to Jeff if you have any questions. Do me a solid like, comment, subscribe, share with your friends. I appreciate you, and I'm out.